There's some basic boat operating principles. One of them is ferrying. So with the current coming downriver, we always want to try and keep the nose of our boats facing upriver when we're trying to perform victim pickups or navigate through obstructions or work our way into eddies. Whatever that application is, as long as we're motoring upriver, we have maximal steering control and operational control of the boat. As soon as we're facing downriver, we lose a lot of those performance characteristics and responsiveness from the motor and from the boat. So remember to always get your nose upriver when performing those applications. When we talk about ferrying, we're talking about adjusting the nose of our boat 15 to 30 degrees, facing upriver, allowing that current to push towards the side of the boat as we're orienting, and allowing our boat to kind of navigate left to right while either hovering or holding position or working our way upriver. So remember, the stronger the current, the more reactive the boat. As soon as your nose comes off directly upriver, if it's heading towards the left side, your boat's immediately going to start traveling towards the left side. If it's heading towards the right side, the boat's going to naturally start traveling towards the right side. The stronger the ferry, the stronger the reaction. A lot of times we have to counteract that reaction, particularly when we're picking up victims. So if we collect a victim on one side of the boat, for example, the right side of the boat in this application, I would have to ensure that my rudder control counterbalances that to prevent us from altering our ferry angle and moving towards bank. So if I want to intentionally hold position, as soon as we take that victim on the right side of the boat, it's naturally going to pull the nose of the boat over towards the right side. To counteract that, I have to do an opposite action on my motor, throttle up without losing the victim, and control that position. So understand the current conditions, and understand those ferrying operations. It's also important to talk about loading the boat when we're making turns. So the safest possible application, particularly in John boats, to prevent rotational capsizing, is that we always take our rescue personnel that are in the boat and we put them on the downriver side of the boat when we're making turns. The way that translates is, when we're traveling upriver, if I call hard right, all my personnel in the boat are going to go to the right side of the boat. If I call hard left, all my personnel are going to go to the left side of the boat. It's the exact opposite when we're traveling downriver. So if traveling downriver and I call hard right, it's going to be all of our personnel to the left side of the boat. If I call hard left, it's going to be all of our personnel to the right side of the boat. Now, you can't use those as absolute applications. You need to understand your boat, how much it's going to dip, and what the possibilities are of it taking on water when you're making those turns. In downriver applications, one example of where we're going to lean into the turn or on the upriver side is when we're trying to do a downriver eddy turn or negotiate an obstacle where it's imperative that we make a very tight turn. So understand your boat, understand its limitations, and apply your boat loading with terms appropriately based on your boat's performance capabilities. The key ingredient is to making sure that you don't take in water on the upriver side of the boat when making turns and result in a rotational capsize of the craft. Okay, when we go through each boat, we're going to talk about the different craft characteristics and how they handle on the river. So one of the unique things about tunnel hole craft, like the Tinga boat that we're in now, they are very reactive. They don't shift across the water at all. They basically operate on rails, which are the hijackers that run underneath the sponsons. And when you want to turn or ferry, they are incredibly reactive. Right now, the great thing about doing downriver eddy turns in crafts like this is you're not going to have any washout. And basically, the front nose of the boat picks up out of the water and just repositions itself. When we perform those same maneuvers with John boats or standard V-bottoms or inflatable craft, normal inflatable craft, you're going to find that you have to get yourself a little bit further away from the objective when you go to drop in, because the turns just aren't as tight and aren't as reactive. So there's some generic principles about operating crafts, but you really need to spend time in your boat to learn your boat, to know your boat, and to understand its turn radiuses as well as how you operate it. All right, when we seek eddies in our craft, we're gonna have upriver approaches and we're gonna have downriver approaches. There's basically a current differential or a keeper behind any significant obstruction in the river base. So what you want to do is you want to ferry your boat over when you're traveling in an upriver application, drop into that eddy, and as soon as you're in that current differential, if you're still under a lot of throttle because you're resisting a lot of current, you got to make sure that you get off the throttle and dial it back down, and sometimes you even have to goose it in reverse just a touch to prevent from slamming into that obstruction that's creating this eddy. Once you're in that zone, it's a safe point that can completely keep the boat right where it needs to be. You just got to watch your rudder control. These are great havens to seek, to either make operational changes to your craft or to deploy throw lines and reach lines to our victims to try and bring them into these areas to go ahead and procure them, particularly when we're in current that's significant enough that we're not navigating upriver real well or real effectively. So that's our upriver application. On a downriver application, when we come into eddies, we want to be about 1 boat length away from the object or closer. And when the nose of our boat is in close proximity to that objective, we're going to do a tight peel turn into that eddy, which basically brings the rear end of the boat around and drops the craft right into that eddy. You want to make those turns tight, but you really got to watch swamping your boats or capsizing when you lean into those turns coming into those eddies. As soon as you drop into the eddy, also ensure that all your personnel neutrally load the boat as soon as you drop into it so that the boat doesn't pitch the other direction. And as soon as you drop in, immediately off the throttle and let that objective keep you right where you're at. When we come out of eddies, we have 2 choices. We can either do a downriver eddy turn, so as we would push off of the objective, set a ferry angle coming towards the width of the river, and then do a tight turn, headed downriver, and then get turned back around to head towards our objective. Or we'd set our ferry angle coming out, and as we come out of that crest, we're gonna have to counteract what that river's trying to do to the ferry angle we've set, motor it around, and then start trucking upriver.